All right, how's everyone feeling today? My mouse was all right. Today is Monday, February 19th, and that means that test 1 week is officially beginning. This afternoon at 1:30 will be the first time that I give this particular test this week. You should report to this room at 1:30 on either today, Tuesday, or Wednesday to take the test. You can attend whichever day you normally attend for lab. You will attend instead of lab, so just in case you haven't heard it yet, there is no lab this week, you are taking the test instead. And if your schedule allows, you can attend a different day than normal if you prefer. Again, if your schedule allows. Monday and Wednesday, it'll be me, and since Dr. Edwards covers my Tuesday labs, he will be proctoring the Tuesday tests. And whichever one of us is in the room, the test is still written and the proctor is given instructions for you to ask questions and for the proctor to make sure that you understand everything that's going on. Now, class today and also Wednesday will be entirely geared towards test review. I'm not going to give you any new material on these days. I'm going to answer any questions that you guys have as you are studying to make sure that the test, that you are ready for the test, whether you take it this afternoon or one of the following 2 afternoons. Whenever you take it, you can just consider yourself done for the week until Friday. Friday's back to normal because test is done by then. Friday we will either be learning or I'll be giving your tests back depending on how quickly I grade them. So Friday is normal, but lecture these 2 days are review. If you feel you don't need the review or you take the test today or Tuesday, you can have any lecture you need off. But again, Friday is normal. Report to normal on Friday. To help with your studying, there is practice questions and past homeworks you should be doing. I have also gone ahead and run off many copies of the course formula sheet. I do need to add a page to it before test 2, but every formula you need for test 1 is already on here. And in fact, there's some you don't need on here because this is kind of my general formula sheet that I use for most of my classes. So if something on here doesn't look familiar, there's a chance that you haven't covered it and you don't need it. I will gladly tell you what things on here you can cross off. If you have your own copy, great. If you don't have one yet, you can grab one of these. You will be encouraged to have one of those and a non-cell phone calculator during the test. So, I know I probably said most of those things several times over the past couple of weeks, but I tend to repeat myself, don't I? So, all that said, how are you guys feeling? What's on your minds? What questions do you guys have as you've been studying to make the test? Make sure you are ready for the test. Yes.
I was wondering, is it gonna be like in general, like all like the homework questions combined on the test, or how is it?
Similar, yes. The test currently has 12 numbered questions on it, and kind of like the homeworks, each one will sometimes be a multi-parter, which is to say it might present you a scenario and then ask you a couple different things about that scenario. And some of the test questions are literally either ripped straight from the homework or slight modifications of the homework. So if you've done the homework, you'll be fine. Additionally, if you've done the practice questions posted to Brightspace, you should be fine. I would say if you're looking for formatting for the test, looking at the way that I format the practice questions isn't a bad thing to glance at. It is slightly different though. The proper test itself is again 12 separate numbered questions. Each one might ask you a couple different things though. Like if there's a question about net force, it might present you with an object and forces are acting on it, and then there's a couple different questions about the types of things that you could examine given the forces on that item. For example, I think that number 4 on the practice test is a good example of that sort of thing. But they don't all look like that. They don't all have 4 sub-parts to them. Some of them are designed to be a lot shorter. Like, there's always going to be one question that's identify the laws of motion. Some of the questions will just be entirely concept-based. Some of them will be mixed between concept and math. And in terms of formatting, this is a pretty good idea of what you should expect to see. But I do usually put lines for you to write your answers on. I always include space for your work, but also lines for your answers. If there's 4 parts, I'll put 4 lines labeled A through D. Just because I like it when you write your answers in those pre-designated spots, because it makes it easier for me to find them and then quicker to grade. So please put your answers on the lines indicated where possible. A slight difference between the practice test and the actual test is each question will also tell you how many points it is worth. There's 105 points worth of question scattered between 12 questions, and each one ranges from like 4 points to 12 points depending on how many parts it has. This doesn't list any points, but on the actual thing, if it's a low point value question, that's kind of meant to be, there's not many parts to this, you don't have to worry about it too much. If there's multiple points to it, then it's okay if it's taking you a minute. And again, it's 105 out of 100. There's bonus points built in. Bless you. Did I answer the question? Okay. I think I got off on a monologue there, sorry.
Can you go over can you go over number 6 on the practice test?
Absolutely. Let me pull up my answer instead. Hold on. I'm trying to find my downloaded copy so I can make it bigger than just looking at the minimized version on the right space. All right, so this is the answers document to the practice questions. The first page, all the concept questions are typed out in red. Second page onward, all the math questions are worked out in red ink. You said number 6?
Yeah.
All right. So number 6 is a collisions question, and the main thing I'm looking for you to be able to do here is recognize that momentum will be conserved in this collision, and you can use that to figure out the final velocity of the combined 2-car system afterwards. So, and you don't have to do the same things that I do necessarily. There's a couple different ways that you can write out your work, but I always like to draw a picture and then show conservation of momentum. So here in the picture, I've got the initial conditions, 5 kilogram object moving at 1.2 meters per second, 20 kilogram object that is stationary. After they crash, they will combine. This question does say the 2 cars stick together and travel as one. They're going to have an inelastic collision. They're going to stick together and move at some different united final velocity, akin to some of the examples we worked in class. Now, to apply conservation of momentum, total momentum initial equals total momentum final. What I've got here is separating these 2 terms into the sum of each object's momentum, both initially and finally. So this is momentum object 1 initial plus momentum object 2 initial, and then the other side, each object again, but the final momenta instead. Again, comparing the total amount that exists before the crash, the total amount that exists afterwards. We know that the totals need to remain the same, even if it's distributed differently between the 2. And then just, instead of momentum, wrote in the formula for momentum. So momentum 1 initial becomes mass 1 times velocity 1 initial, just the formula for momentum and doing that for each of the individual terms. So momentum 2 initial becomes mass 2 times velocity 2 initial. Momentum 1 final becomes mass 1 times velocity final. Momentum 2 final becomes mass 2 times velocity final. It's just one shared final velocity here. Since they are stuck together, they don't have two different VFs, it's one combined VF. It's important to note whether the two things stick together or not. I will always tell you if they do or don't in the text. Then, plugging in the known numbers from there, we've got the masses of the two. I've just decided that the 5 kilogram is mass 1, so I'll try to use 5 for M1 and 20 for M2. Mass 1's initial velocity is 1.2 meters per second, mass 2's is 0. So mass 1 is bringing all of the momentum into this situation, but after the fact, all of mass 1's momentum will be split between the two. On the final side, we've got the two masses times, again, their shared final velocity. That's the same VF in two positions. So there's a few math properties we can take advantage of there, excuse me. Any questions at this point?
No, I think I'm okay. All right, that makes sense. I see what you're getting at.
All right, just to finish things out then for the rest of the room. The left side is gonna simplify down to just 6 because 0 times anything just goes away. 5 times 1.2 is 6. The right side, these can add together to become 25 VF. You can either do that directly or use the distributive property. Both are correct. So that gives us 6 equals 25 VF. Divide both sides by 25 and you get VF equals 0.24 meters per second. The combined two-cart system is moving much slower than the first one was initially because the first object's momentum is now split across both, and a lot of it had to be used up getting the bigger object to start moving. To kind of compare this to the real world, this would be if a Volkswagen Beetle approached and collided with a stationary semi-truck. They're not going to drift very fast after the fact. So how's this one feel? And well, first, any other questions about this one while it's on screen? All right. What else is on your minds?
Can you also go over number 8 on this one, please?
Absolutely. Number 8. How much work is done lifting a 30 kilogram object up a 100 meter tall ladder? How much GPE does the object have afterwards? So my goal here is kind of similar to one that we did in class on Wednesday. We're finding the work done to lift something and comparing that to the GPE that it gains after being lifted to that height. Formula for work is work equals force times displacement. We're going to lift it 100 meters up. So the displacement, I just wrote delta y since it's vertical. The displacement is going to be the 100 meters. And then we have to find out how much force is being used in this scenario. So how much force does it take to lift a 30 kilogram item? How would you go about finding that?
Force of gravity plus mass minus gravity.
Correct. Oops. To lift anything, you have to overcome the force of gravity acting upon it. 30 kilogram object, I'm just kind of making the picture I drew bigger. All of my markers are terrible, and I don't have a trash can to put bad ones into. So, to lift anything, Earth's gravity's pulling down no matter what, you're gonna have to use at least as much force as its weight to get it to start lifting. So, force of gravity acting on a 30 kilogram object, we've got mass of 30 kilograms times g, we use -10 for that. The force of gravity is gonna be -300 newtons. That means, in order to lift this thing, we have to be exerting a bare minimum force of +300 newtons. And so that is where the 300 in my work comes from.
Is that how you got it to be positive 300 times?
Correct. It's not negative because it's technically not the same force arrow as the downward pointing gravity vector. It's a different upward pointing force vector that happens to have the same magnitude. So again, the rule that you can remember, to lift anything, the force required is at least equal but opposite to the weight of the object, if there's no other forces vertically acting on it.
Is that 120 times 300? Or is that 100?
That's just 100. My
Okay.
handwriting's not great. Let me rewrite that on the board. Bless you. So, the positive upward pointing force we are exerting, again, at minimum equal in magnitude to gravity, but not with the negative sign, because it's us working up instead of gravity working down, times the change in height of 100 meters, and that is where 300,000 joules comes from. No, 30,000, my bad. For context, 11 meters, 100 meters, that would be, about a 10-story building. No, 33-story, wow. My math is way off today, it is Monday. It's about a 33-story building. Yes?
You don't have to do the full thing, but for number 9, what C is asking, I got kind of stuck on that one.
Okay.
Like what the difference between C and D.
Yes, I will do that in a minute. I'm suddenly realizing though, absolutely, that is the next thing I'm gonna talk about. I'm realizing I think I just made a mistake in my answer key, because that's 30,000. This is also supposed to be 30,000. I think I added an extra 0 here by accident. So this answer is supposed to be 30,000. The GPE gain at that height is also supposed to be 30,000, not 300,000. I miswrote, sorry. So if you've been looking over these, 30 times 10 times 100 for the GPE formula should also be 30,000. I added an extra 0 there by mistake. When you lift something, the work you do is equal to the GPE the object gains. They're meant to be the same number. Does that cover this question? Okay. You're welcome. One small detail that I'll just point out before moving on to 9C is on the equation sheet, I've added an absolute value bracket around the G in the MGH part of the formula. This is because, since energy is a vector, it doesn't care about the negative sign that we normally put on G. whether you use -10 or -9.81, GPE doesn't care. It doesn't want the negative sign, because it's not a vector, it doesn't care about direction. And technically, if you look very deep into the math, the negative cancels out when you use the calculus version of this formula. For simplicity's sake though, on the formula sheet, I added an absolute value bracket because this formula does not care about the negative that is associated on the G. Absolute value means if it has a negative sign, you make it positive before you do anything else with it. I have changed the formula sheet to reflect that. If you have your own notes, you should, or printed out an earlier version, you should add those as well. Again, that's supposed to be 30,000. Okay. Again, just double checking. Feel good with 8? Okay. Cool. All right, 9, specifically 9C. This question, I wrote it with the idea of it being an energy conservation question. Just kind of going through the preamble, getting up to part C. We are throwing an object straight upwards, starts at height 0, its initial velocity is 20 meters per second. When you first throw it, the type of energy it has is KE, height is 0, so it doesn't have GPE, but it does have a velocity. So this is the form of energy it has. Part B is calculating how much energy that it had, how much energy is in that state. And then part C asks, does the ball's total energy level change as it rises? And the answer here is no. The reason for that is the conservation of energy. Total energy level in the entire universe, but also for individual systems, must remain constant. So what I'm trying to, the question I'm meaning to ask here is, the ball has 400 joules of energy initially, specifically in the kinetic state. And that total will remain the same even if the form of the energy changes from start to finish. So part C is asking, does the total amount of energy drift away from being 400? No, but the kinetic energy value will change. Kinetic will drop, but it'll still have 400 joules total. And so, yeah, admittedly I showed it in part E, but here I've got conservation of energy. Total energy initial equals total energy final. Initially it's all in the kinetic state, and by the end it's all going to turn into GPE. So KE initial is going to be equal to GPE final. There's no GPE over here because you're at height of 0. Meanwhile, when you rise to your max height, you stop and have no KE left. So the GPE initial is 0, and the KE final is 0. So it's just KE turning into GPE from start to finish. So that total amount of KE is going to fully turn into GPE at a height of 20 meters. Does that answer the question? Okay. Anything else on your minds right now? Across notes, homework, practice questions.
So is the homework more efficient or this is?
If your goal is, I suppose if your question is, just to make sure I'm answering the right thing, what to focus on to best practice for the test specifically, I'd say the practice test. the homework's kind of designed as what you do in your spare time to make sure that what you're learning day by day makes sense, or at least chapter by chapter. And then this is applying all of it to a pseudo-test environment to then apply it to the test environment.
Okay.
So if you only do one thing, I'd say make it this.
Thank you.
You're welcome.
How long do you think the test is supposed to take?
I-
Like full lab time?
Well, I write it to take you guys an hour, because if we were doing it in class, you'd have an hour to 50 minutes, technically 50 minutes, I suppose. So I write it to that standard, but I give it during lab time so you can take longer. That helps people with academic accommodations, but it also means that no one has to rush in, finish it in 50 minutes, and then rush out. So I write it to take an hour. You will have up to 3, because I'm going to be here anyway. Like, it's written with the intent of everyone getting a shot at every question, and at a certain point, if you're just staring at it for, like, you kind of hit a point where you've done everything you can anyway, so I think putting a time limit on it's not all that helpful. Did I answer the question? That answers the question, right? Good. Anything else on your minds right now? It's okay if not. Sometimes you don't know what you don't know. If there's nothing you want to talk about right now, we can kind of pause. I'm going to be in this room anyway. I'll just pause the recording until someone has something they want to speak out about. And you guys can study quietly or go about your business. Again, this is free-form review week. So, again, I'm just going to pause so I'm not recording dead air.